In this video, we're going to be looking at multiplying two functions. So I have f of x is equal to x squared and g of x is equal to square root of x. I want to find f g of x. Well, f g of x, we learned, is the same thing as f of x times g of x. So here my f of x is equal to x squared and my g of x is equal to the square root of x. Well, how do I multiply those? One is in exponential form and the other is in radical form. Well, we learned that we can go ahead and rewrite this one that's in radical form into exponential form. And I can do that by saying this is equal to x squared times the square root of x is the same thing as x to the 1/2 power, because that index here is really 2. And then we learned from our power property that x squared times x to the 1/2 is the same thing as x to the 2 plus 1/2. And so that means that f g of x is equal to x raised to the 5/2 power. Okay, next I need to state the domain. So here are my two functions. I have x squared and then I have square root of x. And so the domain of f consists of all real numbers and the domain of g consists of all non-negative real numbers. And so that means that the domain of fg consists of all non-negative real numbers, or in other words, that x is greater than or equal to 0. And remember, that's because that square root of x, that x has to be non-negative, because if I have a negative x and I take the square root, I get imaginary numbers. Okay, and then it says to evaluate the product when x is equal to 9. And so I have fg of 9 is equal to 9 raised to the 5/2 power. And so there's a couple of different ways that you can do this. You could go ahead and type this into your calculator, or you could rewrite this into radical form. And so that 2 is my index, so it's the same thing as the square root of 9 raised to the 5th power. Well, the square root of 9 we know is 3, so it's the same thing as 3 raised to the 5th power. And 3 raised to the 5th power is equal to 243. Okay, let's look at one more. So I want to find fg of x. I know that's the same thing as f of x times g of x. And so here f of x is 6x, so I have 6x times g of x, which is x raised to the 3/4 power. And so here I'm going to do that same property that we did in number 1. My x here doesn't have an exponent, but whenever that's the case, there's really an imaginary 1 right there. And so when I multiply these, I get that this is equal to 6 times x raised to the 1 plus 3/4 power. And so adding those, I get 6x to the 7/4 is equal to my f g of x. Okay, next when you look at my domain, the domain of f is all real numbers, but the domain of g, I have x raised to the 3/4 power. And remember this 3/4 power, that's the same thing as this being equal to the 4th root of x raised to the 3rd power. And remember, whenever our index is even, our x has to be non-negative. And so that means the domain here is going to be the same as number 1, as in that it's going to be x is greater than or equal to 0. And then now lastly, we're going to go ahead and find fg of 16. And so plugging in 16 for x, I get 6 times 16 raised to the 7/4 power. I can rewrite that 7/4 to be 6 times the 4th root of 16 raised to the 7th power. Well, the 4th root of 16, that's equal to 2. So this is 6 times 2 raised to the 7th power. 2 raised to the 7th power, I get 128. So this is 6 times 128. And when I multiply 6 and 128, I get that this is equal to 768.